Hello everyone. In this video, we will again use the trigonometric identities to prove or verify the identities. So this is another kind of question that they may ask based on the trigonometric identities. Okay. I hope you remember from my previous video the trigonometric identities that I have asked you to memorize. The quotient identities, reciprocal identities, Pythagoras identities, and the even and odd identities. So if you remember this, based on this, the other way of asking the question is here. So they may ask you, prove that cos x minus cos cube x is equal to cos x multiply sine square x. So in this case, what you do, since this is an equation, one side is the left side and the other side is right side. And you have to prove that left side is equal to right side. So what you can do, you start with any one side. Say let's start with left side. Prove that this value is same as the right side and then you are done. So let's write what is the left side. This is, yes, cos of x minus cos cube x. Okay. So now how do we simplify? So you have to check if there is any greatest common factor between these two terms. So do you remember how do we find the greatest common factor? Cos of x, you can write it as cos of x only, okay, or 1 multiply cos of x, okay, the factors. Now if you have cos cube x, how you can write? It is means cos x multiplied 3 times, right? Because the power is 3. So if we find the greatest common factor from this, what is it? We can write 1 multiply also. So the greatest common factors are 1 and cos x. So it is 1 multiply cos x, which is nothing but cosine of x, correct? This is how we did with the numbers. Okay, so now from these two terms, we write cosine of x as the greatest common factor. Now, from here, if cosine x is gone, what you left with? Only 1. Nothing means 1. And here what you left with? Cosine x, cosine x. How many times? 2 times. So this is cosine square x. Okay. Now cosine of x. So you got the first term. So you have to get this sine square x. So check, is there any identity that gives you the value of 1 minus cos square x as sine square x? Yes. We have the Pythagoras identity which says that sine square x plus cos square x is 1. So if we move this cos square x on the other side, what we get? 1 minus cos square x. Now use this here. So this gives you sine square x. Now you see, this is same as the right side. So hence verified. Okay, clear? Let's take another one. Same thing, you have the left side, you have to prove it equal to the right side. Okay, so see, it's not necessary that you always work with the left side. You can also start with right side, but you need to check like where you can see the identities, like, okay, means where you can use identities easily so that you can work on it. So if you look at here, suppose you start with left side, okay, which is 1 plus sine square x over cos square x. Now you have to prove that this is equal to 1 plus 2 tan square x. So for that, you have to maybe use many identities. Like as of now, you say that sine and cosine are in the simplest form. So how you can work with it. So what you can do here is, first thing is you can simplify, split the terms. So you can write it as 1 plus cos square x sine square x over cos square x, like this. Okay. Now 1 over cosine. So it's same as 1 over cos x and its power 2. And this is same as sine x over cos x and its power 2. Now we know that 1 over cos is secant squared x, correct? Sine over cos is tan and the power 2 means tan squared x. Okay. Now check what you have to prove. You want to prove it equal to tan. You don't need secant. So just recall, is there identity that relates secant with tan? Yes, there is. One identity says that 1 plus tan squared x is equal to secant squared x. So use this identity to get your value. So in place of secant, you write 1 plus tan square x plus tan square x. So this gives you 1 plus 2 times of tan square x, which is your right side. Okay, and hence proved. See, this question you can also start with the right side and work. Because you know tan is sine over cos, so you can work in that. Okay, let's go to the next question. You have to prove that. See, there is a bracket here for secant x and this bracket. You have to prove left side is equal to right side. Now, right side is very simple. You can't work on anything over there. So in this case, you don't have choice. You have to start with left side. So this is cosine of x bracket tan x minus secant of minus x. Okay. So first use the negative one. So you know that cosecant x. So let's use for tan. Tan, you know that it is sine over cos minus secant of minus. So you know that secant of minus is secant of x. Okay, because it absorbs the negative sign. So this is cos. This is same sin x over cos x minus secant is reciprocal of cos. So you can write this as 1 over cos. Now it is a difference of two fractions with same denominator. So how you can write cos x sin x minus 1. Okay. So this is same as cosine x multiply sin x minus 1 over cos of x. Now since these two terms are in multiplication, you can cancel them. So this gives you sin x minus 1, which is your right side. Hence, proved. Okay. So the key idea is to start with one side, use the identities, simplify, you will easily get the right side. Let's see one more. So here what you have, sin x plus cos x power 2 is equal to 1 plus 2 sin x cos x. So if you remember this rule, a plus b power 2, what it says, a square plus b square plus 2ab. If you don't remember this rule, what you can do, you can use a plus b square as a plus b, and then multiply. So even if you work with it, you will end up with the same rule. Okay. So let's use this rule because you have studied this earlier. So let's start with the left side. So what you have, sin x plus cos x and its power 2. This gives you sin square x cos square x plus 2 times sin x cos x. How did I get this thing? I'm using this as a, this as b. So this is a square by the rule. This is b square 2 times ab in this rule. Okay. Now, what is sin square plus cos square? We know the identity. It is 1 plus 2 sin x cos x, which is your right side. Hence proved. Okay. Let's see. Here you have two terms on the left side and three terms on the right side. So check, you have cos and tan. You need sine and secant. So it means you need to convert cos into sine and tan into secant. So you have to look for that identities. You know that relation between cos and sine by which identity? You know that sine square x plus cos square x is 1. So when you want to relate cos in terms of sine, so you have to move sine to the other side. So this gives you cos square x is equal to 1 minus sine square x. Okay. Now for tan, you know that 1 plus tan square x is secant square x. Now you want the value of tan, so you move 1 on the other side. So this gives you tan square x as secant square x minus 1. So let's use these two values in our left side. So we have cos square x minus tan square x. Let's see what we get. So cos square is 1 minus sine square x minus. Now since tan there is a negative sign, it's important to put this result in a bracket. It is secant square x minus 1. So this gives you 1 minus sine square x. When you work, this minus goes with both the terms, giving you minus for secant and plus for 1. Secant square x plus 1. Adding this 1 and 1, you get 2 minus sine square x minus secant square x, which is your right side. And hence root. See, in this case again, you can also start with the right side. But what you have to do? You have to find the value of sine in terms of cos. So you will be using sine square x is equal to 1 minus cos square x. And secant square, you will be using 1 plus tan square x. Let me just do this one by other way. Let's see. If I say or, you start with the right side. Okay, what you have? 2 minus sine square x minus secant square x. Okay, so this gives you 2 minus. If I want to find the value of sine from here, sine square x, what it will be? 1 minus cos square x, correct? So since it's minus, I'll write 1 minus cos square x minus secant square x. I will use this result direct. Again, I'll put a bracket 1 plus tan square x. Okay, so what this gives you 2, distribute this minus sign. Minus 1 plus cos square x. Again, distribute this minus sign to both the terms. So you'll have minus 1 minus tan square x. Clear? Because this minus goes here and here. Same way, this minus also goes with both the terms. Now what you see, 2 minus 1 minus 1. So 2 minus 2, it becomes 0. Okay, so what you left with? 0 plus cos square x minus tan square x. So this is cos square x minus tan square x, which is your left side. So see, in this case also, you can start with right side and prove it equal to left side. But remember, you have to do any one. Don't do both. Either this way or this way. Okay. I hope it is clear.